Hello and welcome to this first lecture on this new topic on identifying potential bottlenecks in this course, AI for Project Planning Excellence. So in this particular section, we will give you a good idea of how to use AI for excellence in identifying potential bottlenecks. And we will begin by taking a look at doing the real-time bottleneck detection by monitoring project velocity and dependency and having AI flag tasks that are at risk of delay. So how do you think you can, do the real-time bottleneck detection by monitoring project velocity and dependencies and have AI flag tasks that are at the risk of delay? Any thoughts on that? You know, to use AI to flag tasks that are at the risk of delay in real time, what you need to do is to combine machine learning, real-time project monitoring, and smart alerts to proactively surface risks before they become blockers. Now, what exactly do you need to do? Let's take a look at the various steps that can help. So, first is to collect real-time task data. You pull structured and unstructured data from project tools such as task management systems like Jira, Trello, Asana, ClickUp, time tracking tools like Harvest, Toggle, Clockify, communication platforms like Slack, Teams, emails, and version control systems like GitHub and GitLab. Now, what are the real-time features? What are the key real-time features that you can use? So let's take a look at by category. If you want to track the progress for that, you have examples like percentage tasks completed, missed sub deadlines. In terms of time, you can see actual versus planned duration. For collaboration, you can use features like comments slowing, fewer updates, response lags. In dependencies, you can see predecessor delays, block status. In resources, you can say assigned person on leave or overloaded. And in sentiment, you can look at features like NLP on team comments, frustration, and uncertainty. So that's how you can collect real-time task data. Then you define and learn the delay patterns. You use historical project data to train AI model to recognize what a delay is in making, looks like. And there what you do is you label past tasks which are delayed or which are few days late. Now when you say delayed, it could be binary true or false. And you extract features like, task aging speed, incomplete checklist items, number of blockers added, resource changes, and communication volume dips. So with this, you'll be able to define and learn the delay patterns. Your AI will be able to define and learn the delay patterns. The third would be to train a predictive model. Now, there are many models that you can use. Let's take a look at them. You can use random forest or XGBoost, which has high accuracy with explainability. You can use logistic regression for simple binary at-risk classification, or LSTM or time series model for sequential task progress analysis. And you can use isolation forest or anomaly detection to detect outliers in the task progress. And your output would be task scores on 0 to 1 for each task, and a binary flag at risk versus on track. So that's how you can train a predictive machine learning model. Then you generate real-time flags and alerts. The threshold based alerts are like, you for some examples of that. An example of that will be if the delay probability exceeds 0.75, the AI can flag it as an at risk. So that's an example of a threshold setting. And the triggers could be red flag icons that it can send, manager notifications, auto escalation on critical path tasks. The second thing you can add in the flags and alerts is the explainability layer. There you can use tools like SHAP to explain task is at risk because the predecessor delayed plus resource unavailability plus no activity in last 3 days. So like this, you can generate real-time flags and alerts. Then you are ready to integrate with dashboards and project management tools. You can display red flags using a variety of things like Kanban, board overlays, the red icons there, risk heat maps by project and sprint, and daily summary email or Slack alert. Say, for example, an email or alert saying that 3 tasks are now at risk. So, like this, you can integrate with dashboard and the project management tools. Let's take a look at an example of AI flagging tasks that are at the risk of delay. So it could look at task 42, a task of QA regression testing, and the status could be that it is 3 days behind schedule. The risk score is 0.87, and the cause is it's blocked by development task plus resource on leave and no update in 4 days. And the suggested action from AI could be reassign or escalate blocker. So like this, AI will flag tasks that are at risk of delay. So let us take a look at the tools and frameworks that you can use for AI to flag tasks that are at the risk of delay. So for top of the list is scikit-learn and XGBoost that you can use for machine learning modeling for risk detection. Then there is Spacey and BERT, which uses NLP for comments and sentiment analysis. SHAP for feature attribution for transparency and explainability. ClickUp and Jira API for task and status tracking, and Power BI and Tableau for live dashboards for managers. So these are some of the tools and frameworks that can be used to flag tasks that are the risk of delay. So let's take a look at the real world use case. The company here is Atlassian, using machine learning on Jira project state data to predict at-risk tasks in agile sprints. And the impact of doing this has been that it has reduced last minute rushes by 25% and improved stakeholder trust with early risk visibility. So that's a real world use case example. So what do we do next? So in the next lecture, we will take a look at another part of identifying potential bottlenecks, and there we will look at dependency mapping, where AI can detect complex dependencies that may slow down the progress and help you identify the potential bottlenecks. So thank you so much for watching this lecture on identifying potential bottlenecks in this course, AI for Project Planning Excellence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.